computational cost and implementation analysis of a wavelet-based edge computing method for energy harvesting industrial IoT sensors. There is a lot going on in that title. Let's break it down at a high level to get the lay of the land, then we'll go deeper. Have you ever wanted to make a video call but your phone was too low on battery? What did you do in that case? If it was urgent, you probably fell back to an audio call. If the battery was too low for that, you might have just sent a text instead. If it wasn't urgent, you might have just waited until your phone was charged. This kind of decision tree makes sense because each option sends a different amount of data, and sending data consumes energy. When you don't have much energy, you shouldn't send much data. If you have more energy, you can send more data, and sometimes it makes sense to send just a bit, knowing that you'll be able to follow it up with many more details when you have more power. That same kind of branching logic is what's happening in this paper. Instead of you needing to use your phone but it having low battery, we're looking at IoT sensors that need to send data but don't have enough energy. Why don't they have enough energy at the moment? Because these kinds of sensors use something called energy harvesting instead of plugging into a wall. They might get their energy from solar panels or thermoelectric generators or any number of ways that we'll explore later. The point is, they don't have enough power to send all the data they're collecting. So these sensors need a way to adjust their network throughput based on the energy available to the device at the time. That's what this paper is about. There are a number of ways that this could be accomplished, but these authors' particular implementation utilizes wavelet transforms as part of the data preparation process. With that under our belt, let's look at the title again. Computational cost and implementation analysis of a wavelet-based edge computing method for energy harvesting industrial IoT sensors is roughly equivalent to a way for IoT sensors to compress the data they're sending based on how much energy they're getting from the environment at the time. That's the gist. Now we can go a bit deeper. We're going to start by exploring the problem these authors are trying to solve. Then we'll talk about the theoretical foundations of their solution, wavelets and various types of wavelet transforms. Then we'll review their implementation, how they tested it, and the results they obtained. If you're already subscribed to our email newsletter, then you'll be getting this episode in text and audio form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.